Hello, my name is Tish, and I'm going to show you how to interpret a histogram. Let's start though first with why we would do this in the first place. Histograms are a great tool of quantitative analysis, and you see one behind me. If you're interested, for example, in at what point in their life across the globe someone's receiving sex education, a histogram allows you in one shot to display exactly that. The histogram behind me shows the mean ages at which someone across a survey received a sex education. And we're going to use this histogram to convey this information for the whole sample of countries for which we have these mean ages. So, for example, in one country, someone might have received sex education at the age of 12. And this is included in the histogram. How do I start interpreting a histogram? I start by not looking at what's actually displayed in terms of my results, but by how it is interpreted. And the first thing to look at, what is the variable that is displayed? You find that variable right here at the bottom, the x-axis, and it says mean age in years. And we have an age range ranging from 10 to 16. And this is what's displayed. The mean age in a country here at which someone received sex education. The second thing is the second axis, which you find here, the y-axis, which gives you the number of countries for which the mean age is, for example, 12. This is not a variable that you would find in a data set, but this is something that when you create a histogram, or when someone else creates a histogram for you, is automatically created. It's also sometimes referred as the frequency, and it's the frequency within a continuous variable. So what you see here is the count of the number of countries within which someone received sex education at age 12, or actually, if you look very closely, in an age range. If you look at age 12, you see that the bar isn't just around 12, but it goes a bit to the side. So it's really ages around 12, and it has to be because mean age isn't a discrete variable, but it's a continuous variable. So you don't have 1, 2, 3, 4, 5, but you have 1.1, 1.2, 1.2, and so on. So the mean age might well be 12.5 years of age, or 12.1. The interesting thing in a histogram is all of this is included in one bar. So now that we've looked at what's displayed, the number of countries that have a specific mean age, and the mean age here is, we can actually go and interpret this. And there are key aspects to look at. The histogram is really good in conveying the distribution of the values here, the mean age. And we want to look at the shape of the distribution and the center in particular. The center of the distribution tells us what's the most common value. You will have relations to that in descriptive statistics with actual values. But here, for example, if you look at the range around 12, well, that's the most common value. This relates very closely to the mode, the median, and the mean in descriptive statistics. The second thing that we want to look at is the range. What are actually the values displayed here? They range from about 11 to about 15.5, 16. So these are the age ranges within which someone, on average in a country, receives sex education. And then the final thing, and this is really the most important thing about histograms, you can also look at the whole shape of this distribution. The interesting thing of this distribution is that it's very much bunched towards 12, not just because it's the most common value, but most values are 12 and slightly below or slightly above. And then it kind of tails off, and really this is how you should think of it, it tails of the distribution towards 60. We refer to this as the skew of the distribution. And this particular distribution is right skewed, with higher values further away from the median, being further away towards the higher end of the range. It's quite helpful to think of these concepts, and if you are interpreting histograms, you should familiarize yourself with them. It's the skew that really describes the shape of the distribution with respect to its center, and then its minima and maxima, the highest and the lowest value. Then there's the question of symmetry, whether the minimum and the maximum are equally far away from the highest point of this distribution, the center of the distribution. And then finally, and this is quite a useful one to describe, it's the kurtosis. How peaked is it? Is it a very flat distribution where the average of the most common value is not very high up, but it's just, one amongst many? Or like here, where it is quite peaked, where the kurtosis is quite strong. So we have now looked at this histogram by saying, what does it display? Number of countries and mean ages. We've described the actual results by thinking about the center of the distribution, the minimum and maximum, which makes the range, and then describe the shape of the distribution. And the key terms here to remember: symmetry, skew, and kurtosis. Finally, whenever you get any graphical display, you should also consider its trustworthiness. Is what's displayed trustworthy and truthfully displayed? And we start by looking again at the axis down here. Are they actually truthful? Are they too wide or too narrow? Do they miss out values? If we were to talk only about age here, we should have an axis that starts at 0 and goes up to round about 100. Since we're talking about mean ages, it's not conceivable really to have 0 values, because we do collect data, and unless a country doesn't have education, you're not expecting a mean age of 0. So it's quite okay to have a range that is more about the values that are actually observed. The second thing to look at is obviously to say we have a title here, which really conveys a question or conveys what the meaning of this display should be. Is this really what's displayed? Well, here it's slightly misleading, because it's not about an individual's age, but it's about mean ages in countries. And the title should somehow convey this, otherwise it's slightly misleading. The final bit, and it's probably most important and often overlooked, is the source. Any good graph should have in the graph, or very close to it when it's posted or when it's shown anywhere, its source. And this should be detailed. This shouldn't be just, oh, this is data from the University of Glasgow. No, this should be, this is data from the 2010 Durex survey. And ideally, where to find this? Here it's publicly accessible, and that makes it even better because it's open data. It has an ISSN number, and you can look it up. These are checks that you should do with any graph: axis, title, and the source. For histograms, there comes one specific addition to it. When I started off, I said, well, these aren't discrete values, these are continuous values. And the bars that you see in it are across a set of values. These sets of values we refer to as bins, because we tip into a bin a set of values, say 12.1, 12.2, 12.3, and call them just 12 and have one bar. Since it's up to the person making the histogram how wide the bin is, whether 13, 14, 15 are also included, you can obviously change the display of the graph considerably by changing the width of the bins, so what's included. And therefore, you should always look whether there's a report, what's the bin width, which you find here in the caption down below, or if that's not displayed explicitly, try to infer it from the axis. And then you can consider, is this a sensible value? Here the bin width is 0.3, of a year. This gives you quite a fine-grained amount of detail. If you have the data available and you were to do this histogram yourself, you might want to say, is this sensible given your data? Here, we seem to get quite a good amount of detail and things aren't obscured. If you take a wider binwidth, you might obscure the detail of the distribution, and you might end up, for example, showing a distribution that has less skew, is more kurtotic, so more pointy, and that misses out on any kind of extreme values or the likes. And with this, thank you very much for your attention. You will find more detailed explanations, examples, and some information on the more theoretical concepts like skew and kurtosis if you follow the link underneath the video. And if you're interested, this is one part of what we do in quantitative methods at the University of Glasgow Q-STEP Center. Thank you very much.